Let's look at the graphs of secant and cosecant. What you're seeing right now, these two graphs, this is not secant and cosecant. This, the one on the left, is the graph of cosine. And the one on the right is the graph of sine, okay? Remember, though, that if we take the reciprocal of cosine, we will get secant. So secant is the graph of 1 over cosine. Cosecant is the graph, or is the function, 1 over sine, okay? Now, I'm going to focus on just the one on the left for a little bit. Basically, it's all of these y values, these cosine values that we're getting, okay? I'm going to take all of them and I'm going to reciprocate them. So this is a 1. If I reciprocate it, I will get a 1. Okay? If you think about this, this is 1/2. If I reciprocate it, I will get a 2. This is a 0, and if I reciprocate it, it is undefined. This right here is a -1/2, and if I reciprocate that, I get -2. This is a 1, and if I reciprocate that, I get 1. This y value is a -1/2, and if I reciprocate that, I get a -2. This is a y value of 0, and if I reciprocate that, it's undefined. Okay, so I'll show you what I have so far. Actually, let me do a couple in the negative direction first. This is a y value of 1/2. If I reciprocate that, I get 2. This is a 0, and if I reciprocate that, it's unknown or undefined. Okay, now let's sketch the graph of what we have here. What you see in red is part of the secant function. Now, we could go here and say, well, the same thing's going to happen. There'll be an asymptote here, absolutely. And it's on repeat. Same thing here, right? Same thing here. So it makes a bunch of u's, up or down. That is the cosecant, okay? We can see that obviously there's a repeating pattern here. And the period, think about a point and then when the point shows up again. Okay. Now, you can't really say, well, it's a 2 here and it's a 2 here. Period's only, 1 pi. No, because you haven't hit any of these other ones that are opening down. So that's not the case. So let's go with, consider this. You have a height here of 1. You don't have a height of 1 again until you get here, right? The pattern, the actual pattern doesn't repeat until you get to 2 pi. So the original period for cosine is 2 pi. Now, when we talk about inverses, we're going to have to shorten that. But right now, we're not talking about inverses. We're just talking about the graph of secant and the graph of cosecant. Okay, and that's the graph of secant. Okay, we're going to go over here and we're going to sketch the graph of cosecant. Notice sine is curved already or sketched for us already, so we are going to reciprocate all of the values, okay? So when sine has a y value of 1, cosecant has a value of 1, okay, there. When the sine function has a 1/2, the cosecant's value is 2. That will happen there, and that will also happen there. When the sine's value is 0, the cosecant's value is undefined. And that happens there, and there, and there. We could keep going, and there, right? So, there we go. What I have so far is this piece, but I'm not done yet, right? Reciprocate this -1, we'll get -1. Reciprocate -1/2, we'll get -2. Reciprocate -1/2, we'll get -2, right? And it's going to keep going and be on repeat for all of these, okay? A bunch of U's up and a bunch of U's down. And we can see here again that if you start, you could start counting your period anywhere. And you got to go till you get to the same point with the same repetition either before it or behind it. So if I'm here at pi/2 and I don't repeat here until I get to here, which is 5 pi/2, I can see that my period is 2 pi. Or asymptote here at 0. Yes, there's another asymptote, but I haven't even established the U that opens down yet. So the pattern doesn't repeat until I get to 2 pi. So period for cosecant is also 2 pi, okay? All right, next, let's throw in some translations or transformations and see what we can do here. Just like in our other notes, they have, come on. Apparently I hit back too many times, so when it decides it wants to work for me. No, not that many times. We will move. Here is our kind of our box of information, just like we had for sine, for cosine, and for tangent. Okay. Now, amplitude, it's kind of a tricky word to use here as well, because amplitude is really going to help us find either the minimum or the maximum of those U shapes, right? For cosine, or, very similarly for sine, it'll help us find those values, right? For the secant and the cosecant function. Original period is 2 pi, so if we have an alteration to the period, we'll divide that by b. Phase shift, vertical shift, and as we saw, there's asymptotes, okay? Now, the types of graphs that we've done so far, we've had 5 key points for. So for the 5 key points for cosine, we will do a minimum, an asymptote, a maximum, an asymptote, and then back to the minimum. Okay, so that's your 5 key points. For cosecant, we will start with asymptote, min, asymptote, max, asymptote. Those would be our 5 key points for that one. Okay. All right, let's go here. Graph one period of this function. This is a secant function. It's the reciprocal of cosine. So I'm going to work my inside out. Period is 2 pi divided by b, which is 0.4. I don't like it when we do decimals with non-decimals as far as like irrational numbers. So 4 is really 8/10 or oh, not 4/10, it's 4/10 or 2/5. So if I change this to 2/5, then we're gonna get 5 pi. Oh, that's really large. Okay. All right, so 5 pi. So this is going to stretch the graph. Yeah, because the normal period is 2 pi. So we're like more than doubling the stretch. Okay, and then the A in the front is a vertical stretch. Now there is no C, so our phase shift or horizontal shift is 0. Okay, so if I'm going to do my 5 key points, 1, 2, 3, 4, 5, and we know they're U's. There's no shifting. Our first one starts at 0. It's going to repeat 5 pi later. Each gap is the period divided by 4. So this would be 5/4 pi. This would be 10/4 pi. This would be 15/4 pi. This would be 20/4 pi, which makes sense. Okay. Now, when it comes to secant, let's look up here again. We had a minimum of the u, and then an asymptote, and then a maximum of a u, and then an asymptote. All right, let's see if we can apply that here. This was a minimum of a u. This was an asymptote. This was a maximum of a u. This was an asymptote. And this one's back to the minimum of a u. Okay. Now, used to be a 1, and now we're vertically stretching it 2.5. And since we don't have a d on the back end, there's no vertical shifts. It's just the stretch. So this will be a 2.5. So 1, 2, 3, 2.5 right there is that minimum of that u. And then 5/4 pi. Let's see, 1, 2, 3, 4, 5. This will be my 5 pi mark. 5/4 is 1.25 pi. So that'll be right here for my asymptote. Okay. And then 10 is going to be 2.5 pi. 1, 2.5 pi is going to be my 1, 2. The maximum. So at 2.5 pi, 1, 2.5, I'm going to be at negative 2.5. And that'll be the max of that, that u. And then 15/4 is 3 and because we get to 12.75 pi. 1, 2, 3 3/4, and that's another asymptote. So this is my U shape opening down. This is my U shape up, and then my start over is going to be here. And there I have 1 period worth. Now, is it on repeat to the left and to the right? Absolutely. So if I wanted to do 2 periods, I would fill in the rest of this, find when the next asymptote is, fill in the rest of this. The nice thing is the secant function is even, so there's symmetry over the y-axis. Okay. All right. Let's look at this next one. It is another secant function, so we kind of know the shape. It's going to be a bunch of u's, right? You know, before I move on, I've referenced midline, but this one I didn't have a vertical shift, right? Like a plus D on the back end, but if I did, it would change that midline. Midline, gap up, midline, gap down before we have any mins and maxes of those U's. So I'm looking ahead at the next example, and I do see that that midline is getting raised 1 unit. So just notable. Okay, so we know we're looking at U's again. I'm going to start with this inside and talk about period first. Two pi divided by pi over 3. Our period is 6. Okay, let's talk about whether we're shifting this whole thing to the right or to the left. So we'll have a shift, a horizontal shift. And remember that C over B, or in other words, you set all of this equal to 0. And so for x, so we'll have a pi over 2 divided by pi over 3. Which is a 3/2, and it's positive, so that's going to the right. Okay. A is 4, so that is a vertical stretch. Okay, positive 4 units. And I'm going to say, this is going to be, it is interesting, but I'm going to say from midline. Okay. And then vertical shift is the D on the back end, which is a 1, so the whole thing goes up 1 unit. So here's how we put this all together. We'll do our 5 key points. I'm going to sketch data points along the way. So 1, 2, 3, 4, start over. Okay. I did have a horizontal shift. Normally, right, normally our secant graph, we start at 0, but we're not starting at 0. The whole thing is horizontally shifted to the right 3/2 units. Okay. 1 period later, remember our period is 6. So that means way over here is 6 units later. So we're at 3/2. I'm going to add a full 6 units later, which is 12/2. So 15/2-ish. Or 7.5 if you want to do decimals. All right. So the full period is 6, and I have 4 gaps. Is 6/4, or in other words, 3/2. So this would be 6/2. This would be 9/2. This would be 12/2. This would be 15/2. It comes out correctly. So I like that. For the sake of space, I'm going to get rid of this. All right. So those are all my x values. Now let's start talking about y values. For the secant function, normal secant function, right? U up, asymptote, U down, asymptote, U up. So normally we're here, then asymptote, then here, then asymptote, then here. Asymptotes are still going to occur here and here, right? This will still be, since our vertical stretch is just 4, this will still be a min of that U. This will still be a max of that middle U, and this will be a min of the one on the right end, okay? Now, the notables here are this entire thing is being vertically shifted up 1. So this, not very graphed well, is the midline, right? At 1. Now, my vertical shift, my vertical stretch is 4 up from that midline. So this min will be at the 5 mark. 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. Okay. So 3/2, 5. 6/2 asymptote. So that's at 3. 1, 2, 3. 9/2 is our min. Now, excuse me, our max of that U that opens down. Now, normally it's 4 units down from the midline, right? Or it's a stretch of 4 units from the midline. Well, the midline's up 1. So this will be at -3. And 4.5. Okay. And then at 6, we're at another asymptote. So we have this part, and then at 5, this is 6, 7, 8, 9, 10, so on and so forth. This is 7.5, and we're 4 up from the midline. So that would be there. And this is 1 period worth, okay? Now, if a period, right, we said that our period was 6 units long, right? So, like this asymptote backs up and is repeated right here. So this is another asymptote. Yeah. This asymptote is at 3. 6 later is a repeat of that asymptote. And the pattern continues. Okay. All right. Let's take a look at a cosecant. Now, this is the reciprocal of the sine function, so we have to remind ourselves what that sine function looked like. Or, excuse me, the basic cosecant function looked like. Well, remember, sine, maybe if my pencil works, sine goes through 0, 0, does that. So that means that the cosecant is this one. Right? Or there's an asymptote here, asymptote here, asymptote here. This is 2 pi, this is pi, pi over 2, 3 pi over 2. Okay? That's the basic sine, which turned into cosecant. Now, we're going to do a bunch of edits to that, alterations, right? Transformations. Looks like we're altering the period. 2 pi divided by pi over 2 gives me a period of 4. Okay. Vertical stretch, 2 units. So rather than being here at a 1 and here at -1, your gap to midline is 2. So rather than this gap being 1, those gaps are 2 units big. Okay. And this +1 on the back end is an entire vertical shift, 1 unit up. So if we're going to do 5 key points, 1, 2, 3, 4, 5. I'm not shifting it horizontally at all. Remember, horizontal shift was C over B, and I don't have a C. So it's still going to start at 0. If that was an asymptote, it's still going to be an asymptote. My period is 4, so 4 units later. Each gap is 1/4 of the period. So there's the x values. 1, 2, 3, 4. That's 1 period. 5, 6, 7, 8. Okay. Now it went asymptote, min, asymptote, max, asymptote. I didn't move that. It just has a mind of its own sometimes. Okay. Now let's talk about what that min is. We had a vertical stretch of 2. So the midline has been shifted up 1. So my midline is here. I'll do it in highlighter. There's my midline. So I'm going to go from my midline, a gap of 2, up. Okay. So that puts me at a 3. At this 2 mark, we have asymptote. So that was this one. From the midline, we have a gap of 2. So that puts us at -1. And that's this one. And we put it on repeat in both directions. All right, I think I will stop this one here and we'll do cotangent in the next video.